Welcome to Terrestrial Biomes. Important section as we look at the entire globe, all of the different environments that exist. And as we start to compare different parts of the globe, we need to understand which different biomes exist and therefore how those biomes are different. So we have a better understanding of how the environment works, how those ecosystems work, and how they're different from each other. I found these cute little smiley face things. Not quite sure what's going to happen here. So off we go. Maybe. All right, ecology. It is the study of how living organisms interact with each other. This is what you are here for. Here you go. Here's your cheetah. After a gazelle, these organisms are interacting with each other, but most importantly, they're also interacting with the physical environment. So ecology is that combination of the two. These are two massive keywords that we need to know here. Abiotic and biotic factors. Every single biome on this planet is due to different abiotic or biotic factors. Abiotic, A meaning like a non. Abiotic would be these are the non-living species that have a major influence on the living organisms. Temperature, water, soil, sunlight. Where our biotic ones, these are living. So this would be the organisms that live in there and what factors are affecting those living organisms. So that would be the animals in there, the plants in there, the producers, what dead organisms, how much do we have, and animal waste. All right, so as the entire globe, we're going to combine all of these different levels that we have, and so we can understand and differentiate them all. An individual, this is my single organism. Population, all of the members of that species in the area, not all on the globe, but all in that area. Community, the species that all live together, all the species in the same area. Ecosystem is a community of organisms, biotic components of the environment. And finally, biome. It is the area of the planet that can be characterized by its climate. This is a big thing, by its climate and the dominant plant and animal species that live there. So this is small. Our biome is massive. And based on the biome, we can kind of predict what type of species will be there. So just like what I mentioned, here's my species, population, community with multiple species, ecosystem, biome, and then everything lives in the biosphere. These graphs are super helpful. Help us to look at temperature versus rainfall. These are the biggest two predictors in terms of different biomes. It is based on the precipitation and the temperature for the most, where when we have low temperature and very little rain, very little precipitation, we have tundra here. So we need to be able to understand how to read these graphs, and they help us understand and differentiate between the different biomes that we're going to be looking at today. Here's a map of all of them. We're going to go through all 1, 2, 3, 4, 5, 6, 7, 8, 9 of these, but it's a great map for you to kind of understand the distribution. In Korea, right here, we are looking at, we're kind of like temperate forest area is where we are, but you can kind of compare everything around the globe. As I mentioned before, that rainfall comparison is extremely important because that water really determines how much growth, how much life it can support. If we have a lot of rainfall, then we can have a lot of producers. If we have a lot of producers, then we can have many more species above it. So tundra, very little rainfall, where rainforest, lots of rainfall. All right, starting with the tundra. This is on the top of our globe. Cold, treeless, with grass, moss, lichen, very little trees, very important pit there, and at the very northern latitudes. You need to know how to read these, and these graphs here give us a great indication of what the biome most likely is. You can see we're comparing precipitation and temperature to months. So this is January, February, March, April, May, June, July, August, September, October, November, December. So by comparing our temperature in those months to the amount of precipitation, we can understand what the biome is we can understand the characteristics of that biome. This one here, for most of the year, if you notice, we are below 0 degrees Celsius. So for most of the year, we're freezing. Abiotic factors. Below freezing for half the year, you have a permanent layer of frozen soil, and because of that, nothing can really grow. Very little sunlight, very little precipitation. Because of that, we've got low primary productivity, so therefore low biodiversity, short growing period, not much can live up there. Taiga. All right, taiga is also found at northern latitudes, not as far as the tundra, so just south of the tundra. This can also be called the boreal forest. I'm going to let you look at this graph by yourself, but you can see we're not quite as cold as the tundra, so there's no permafrost. We don't have that permanent frozen soil. More precipitation, and we are above freezing for half of the year. That's super important. All right, still in the taiga. So we've got long winters, short hot summers, much more precipitation, snow, and the soil is extremely acidic, and that's because of the pine needles. We're going to get into that a lot later. Biotic factors. Oh, look how happy the moose is. The primary productivity is extremely limited because of that. Next up, we have the temperate seasonal forest. This is what Korea is. Japan, a lot of China, and a lot of the eastern US. We have trees. Those trees are going to lose their leaves in the winter, and we're located at a lot of the mid-latitudes. Again, I'll let you look at this, but we've got hot summers. We can drop below freezing in the winter, but it's not going to be for a long time period. And there's going to be a nice amount of precipitation to sustain the large amount of trees and bushes and growth. So abiotic factors, 4 seasons, super important right there. 4 seasons, this is our first area that has all 4 seasons. It does get below freezing in the winter, not a big deal. Long growing season, lots of precipitation, y'all know that. And because of that, because of the trees and the seasons, we have a lot of leaves that drop. And when those leaves drop, it's going to create a very nutrient-rich soil. Biotic factors. Our primary productivity, our NPP and our GPP are going to be very, very high because of this long growing season. Massive biodiversity, and our trees are going to drop their leaves, go dormant. Y'all know that, and because of that, this decomposing makes the soil so fertile. All right, temperate rainforest. This is going to be your Alaska, your California, and then south in Argentina and Chile, that area as well, or north in the Scandinavia area. Same thing, you guys know how to read this, but you should notice we're getting a lot more rain. Our rain numbers are massive compared to the one we were looking at before. And we're also going to get large seasonal temperature variations. So that means most likely 4 seasons throughout the year. 4 seasons, as I mentioned, long growing season, tons of precipitation, more precipitation than we get here in Korea. And then this is really cool. This is often when we're going to get this wet marine air is going to be pushed up our mountain slopes. Sometimes it's seen in Japan, and then definitely out in California and Seattle, Vancouver, that area as well. Very high primary productivity because of our water, our long growing season. Because of that, huge biodiversity. We're mainly looking at these conifers and our broadleaf trees. So the broadleaf trees are the ones that are going to lose their leaves. And then, really cool, this is the new thing that makes it very different from what we have in Korea, is we have these epiphytic plants. And these are plants that are growing on top of the trees. Really neat to see. So these could be mosses, they could be lichens, they could be other plants that are growing on top. So, really cool. Temperate grasslands and shrubs. These are our prairies. Most important, very few trees. Very, very, very few trees here. There's enough rainfall to get small plants, but not trees. We cannot get a lot of trees here. Temperature varies, and we get very little rain. Abiotic factors, low precipitation, hot summers, cold winters, and we have some very rich soil, which is great. Because of the low rainfall, our primary productivity is quite limited. It allows really only grasses and shrubs to grow, no trees. We have a lot of burrowing animals there, large herds, and moderate biodiversity. Not as much, though, as now this next one, which is the savanna. Savanna and the temperate grasslands are very similar. The only real difference here is that this one is dry. It has trees. Haha, we have trees. And they get a lot more rainfall. So savanna is different from the temperate grasslands because we have a very consistent temperature here. We get this area of a lot of rain, but for the most part, we're not going to get the seasonal variation in temperature. It's going to stay the same. Abiotic factors, low precipitation, except for that one area, because that rainfall is going to happen during short monsoon season. Temperature is warm all year, soil's very rich. Our biotic factors, we're still limited, so we have a lot of grasses, shrubs, but we do have trees. We did not have trees in the temperate grasslands. Large herds, moderate biodiversity. Desert, here we go. Deserts, if you've ever been in a desert, oh, stunning. Arid regions, arid means very little rainfall. Because of that, very little plant life, and because of all of that, it's very nutrient poor. You can notice very low precipitation. Look at this, almost none in the summer. Temperature can get cold though, so we're not prohibited from that. All right, abiotic factors, very low precipitation, very hot summers, not always, but it's possible. This is probably the most important part, extreme day-night temperature swings. They could go from 10 degrees Celsius at night to over 35 degrees Celsius during the day. Huge swings. Very low soil because there's not a lot, rewind. Soil doesn't have a lot of nutrients, and it's normally sandy, gravelly, or clay. Because of that, Our NPP is so small. Primary productivity, very low. And the plants really have to work on conserving water. That becomes one of the main limiting factors here. And we have very low biodiversity. All right, tropical rainforest. This is what you imagine as a stunning rainforest in the Amazon. We see it in Africa. We see it all over Southeast Asia. Most important, we are right on the equator. So we're getting very high rainfall, and there's going to be lots of vegetation here. You can see this. Wow, temperature does not change throughout the year, and the rainfall is almost also constant throughout the year. We're talking 2 to 10 meters, so much rain throughout the year. And those hot temperatures are able to sustain so much life. All right, abiotic factors, high precipitation, not much variation in temperature. Soil's low in nutrients though, because there's so many critters down on the ground that anytime leaves fall, they're consumed right away. And their nutrients never really get a chance to fall into the ground. Sunlight, though, is so strong, but very little actually reaches the floor. Only 6% of that sunlight is going to ever reach the forest floor. Super high rainfall allows for very high primary productivity. NPP, 9,000 kilocalories per meter squared per year. Huge. Dense vegetation with huge trees. We've got this gorgeous canopy up top, which is like a leafy roof, and that provides for very high biodiversity. And there's a lot of symbiotic relationships that we're going to talk about between these species. All right, so here's kind of a summary of all of it. You can see the differences in the net primary productivity, 200 for the desert, where the tropical rainforest is up at 9,000. Major differences here, but we need to understand roughly the rainfall and how these ecosystems and these biomes are created. One fascinating bit here that unfortunately polar tundra and desert do make up 33% of the Earth's land. Boreal forest is 22, is next, and tropical rainforest is only 11. Long-term outlook, just something to keep in mind real fast. These biomes are constantly changing because of the climate change. This could be due to changes in the tilt of the Earth. It could be due to volcanic activity, asteroid comets, like constantly over our history of this Earth. These biomes are constantly changing and will continue to change in the future. More resources for you. Okay, and now I gotta show you this at the end of the video. You ready? You ready? These little gems here. Let's make this nice and big. Look at that! Ah! Those are my senior pictures from high school. There's my brother. But so crazy when you come home what you find. All right, I'll see you all in class.